Hello everyone. I am going to report to you about the consumptive use and estimation of irrigation water requirements. First and foremost, I am Daniela Maria Oranes, and I am student 8. The consumptive use or evapotranspiration. We all know that evapotranspiration is the combined loss. Evapotranspiration is a combination of evaporation and transpiration. So the combined loss of water from soil and crop by vaporization is identified as evapotranspiration. And the crop needs water, obviously, for transpiration and evaporation. Now, during the growing period of a crop, there is a continuous movement of water from soil going to the roots, then up to the stem and leaves, and out of the leaves going through the atmosphere. Transpiration, right? And then this water movement is very important. It's very essential for it distributes food to the entire body of the plant. Only a very small portion, less than 2% of water is absorbed by the roots and is retained in the plant, and the rest of the absorbed water after performing its tasks, it will get evaporated to the atmosphere mainly through the leaves and stem. And once again, this is the process of transpiration. Now, some water gets evaporated to the atmosphere directly from the adjacent soil and water surfaces and from the surfaces of the plant leaves. The water needs of a crop thus consists of transpiration and evaporation and is called evapotranspiration or the consumptive use. Consumptive use is the amount of water needed to meet the water loss through evapotranspiration. It generally applies to a crop but can be extended to a field, farm project, or even a valley. Consumptive use is generally measured as volume per unit area or simply as the depth of water on the irrigated area. Now, evapotranspiration is dependent on climatic conditions. Example given, we have here the temperature, the daylight hours, the humidity, wind movement, type of crop, stage growth of crop, soil moisture depletion, and other physical and chemical properties of soil. So, an example of a evapotranspiration as dependent on climatic conditions, I have here a slide where we are going to compare the things that where the plant needed more water and which is located on the left side and on the right side where the plant needed less more water. For example, in a sunny, cloudy, and hot climate, the crops need more water per day than on a cloudy climate. Similarly, crops like the rice and sugar cane, they needed more water than the beans and wheat. And lastly, as an example, uh, fully grown crops, they needed more water than the plants that are just suddenly planted. Now, the actual evapotranspiration, the absence of free availability of water for evaporation, will be less and determined by the extent to which crop covers the soil surface and the stage of crop growth which affects the transpiration and soil surface coverage, and lastly is the soil water supply. Lysimeters. Now, this measures the potential evapotranspiration I have here a picture of a lysimeter. Um, Potential evapotranspiration is measured by growing crops in large containers and measuring their water loss and gains. A correlation of potential evapotranspiration assumes that the climatic conditions affecting crop water loss and evaporation from free surface water are the same. Potential evapotranspiration can be correlated to the pan evaporation. We have, as the formula shown here, the consumptive use or the evapotranspiration. We will get that by multiplying the crop factor of period to the pan evaporation. Now the K here, the crop factor K depends on the crop as well as its stage growth. The main limitation of this method are differences in physical features of evaporation of surfaces compared with those of a crop surface. I have here a table of values of crop factor K from some major crops. We have here the percentage of crop growing season since knowing the maize, cotton, potatoes, peas, and sugar beets. In the next column, we have here the wheat, barley, and other small grains, the sugarcane, and rice. Next, in the absence of pan evaporation data, if pan evaporation data is not given, the consumptive use is generally computed as follow. We can compute it by computing the seasonal or monthly distribution of potential evapotranspiration and by adjusting the potential evapotranspiration for the type of a crop and the stage growth of crop growth. Evapotranspiration of crop can be estimated by multiplying potential evapotranspiration by a factor known as crop coefficient. Balik na siya. So potential evapotranspiration can be computed by one of the several methods available for the purpose. I have here the Bainley-Criddle formula for the consumptive use has been used extensively and is expressed as Q is equal to where Q is the consumptive use of crop in mm. I think it's mu. Then the K, where the empirical crop consumptive use coefficient, it is small letter K, yeah, and F, the consumptive use factor. Now the quantities U, K, and F are determined for the same period. The consumptive use factor, the F, will be expressed as this formula, on where uh, the P here is the percentage of daylight hours of the year occurring during the period. Since it's a percent, going to we're going to divide it by 100, and the T here is the mean temperature in degrees Celsius for the chosen period. I have here a table of the consumptive use coefficient for some major crops. Small letter K. So here in the column for the growing period, the lower values there are for more humid areas, and the higher values are for more arid climates. And here are the monthly, where the maximum value, it is dependent upon mean monthly temperature and stage growth of crop. Now the table here that is shown to you are the list. It gives list of the value of P for different months of a year for 0 degree north latitude. The value of the consumption use is generally determined on a monthly basis, and the irrigation system must be designed for the maximum monthly water needs. Next, we have here where it gives the typical values of the water needs of some major crops for the total growing period of some of the crops. Now, this table also indicates the sensitivity of the crop to water shortage or drought. High sensitivity to drought means that the crops cannot withstand water shortages and that such shortages should be avoided. Like this in the banana. Di ba bang high dito? Medium high, bean, and so on. Support. Potato is also high. So example here. So using the Blaine-Lickriddle formula, estimate the really consumptive use of water for sugarcane. For the data given in the first four columns. Now here is the data of a sugarcane. So we are going to compute only for the row of January, and you can try computing it on your own if you want to. So what is again the formula for monthly consumption use? It is by multiplying the monthly crop coefficient to the what? To the gosh. The percentage, and we were going to divide it to 100 and multiply it to 1.8 times its temperature plus 32. So we're going to try it in our calculator. First, we have here the K, 19.05. And then, 05 times the percentage. 7.38, 7.38 divided by 100 times 1.8 times its temperature, 13.1 plus 32. It is 78.14. So if we're going to continue solving it, it will give us these values. But the question is the yearly consumptive use. What is the yearly consumptive use? So we are just going to sum all of these monthly consumption use, and we will get the yearly consumptive use rather. So if we're going to sum it all up, we will get 1,756.25. Next, the irrigation requirement. Now, based on the consumptive use, the growth of all plants can be divided into three stages. The vegetative, flowering, and the fruiting. The consumptive use continuously increases during the vegetative stage and attains the peak values around the flowering stage. Thereafter, the consumptive use decreases. Now, it should be noted that different crops are harvested during different stages of crop growth. For example, the leafy vegetables are harvested during the vegetative stage, and the flowering are harvested during the flowering stage. And most crops, such as potatoes, rice, corn, beans, bananas, etc., are harvested during the fruiting stage. Effective precipitation is only that part of the precipitation which contributes to soil moisture available of plants. In other words, the effective rainfall is the water retained in the root zone, and it is obtained by subtracting the sum of runoff, evaporation, and deep percolation from the total rainfall. Irrigation requirement is the quantity of water exclusive of precipitation and regardless of its source required by a crop or diversified pattern of crops in a given period of time of the normal growth under field conditions. We have here the irrigation efficiency. It is the ratio of irrigation water consumed by crops of an irrigated field to the water diverted from the source of supply, and is usually measured at the field entrance. Water application efficiency. It is the ratio of the average depth added to the root zone storage to the average depth applied to the field. Now, obviously, irrigation efficiency is measured at the field, and the water application efficiency would be the same. Next, we have here the field irrigation requirement formula, on where it is expressed as where the depth of evapotranspiration is going to be subtracted by the difference of the depth of precipitation and the depth of precipitation that goes as surface runoff and or infiltrates into the ground or intercepted by the plants. And we're going to divide it by the irrigation efficiency or the application efficiency. So if there is an absence of irrigation efficiency, the following values can be used as a guide for in different methods of surface irrigation for different types of soils. We have here the sand, the sandy loam, clay loam, and heavy clay. But if no other information is available, the following formula can be used to estimate the effective rainfall depth. The effective, we're going the TPE means again as the potential, I think it's effective precipitation. Yes, it's effective precipitation. Effective rainfall or effective precipitation, sorry. Provided that the ground slope does not exceed 5%. So we have here two conditions. If the effective precipitation is not given. For example, using the data given in the first four columns for a given crop determines the field irrigation requirement for each month, assuming irrigation efficiency to 60%. It's determining the field irrigation requirement. Mala English. Now, what is again the formula for consumptive use? It is by multiplying the crop factor to the pan evaporation, correct? So we're going to try November. 0.20 times the 118. And we are going to get 23.6. Now, what is the formula again for field irrigation requirement? We will get that by subtracting the consumptive use to the effective or the effective precipitation. which is 6. 6, right? It's not 5. Something wrong with my eyes. And we're we are going to divide it by the uh, irrigation efficiency, which is given yan siya, 0.6, and that would give us 29.23. And that would be the rest of the answers. And that would be the end of my report. So thank you so much for listening.